Welcome. Now, so far in the first lessons, we've been looking at finding the gradient of a straight line. Now, when you're finding the gradient of a line, basically what you're doing is differentiating. So today we're going to be starting the topic itself of differentiation, which is like just basically finding the gradient of a line. Okay. Now, I want us to start really simple. If I have a straight line with the equation y equals to 3x plus 4, then we know one thing, that the gradient of that line m is going to be equal to 3. Okay, so m is going to be equal to 3, and then the y-intercept is going to be equal to this 4 here, right? So what I want us to think about is how we can find these 3 without knowing the two coordinates. Remember, in our previous lessons, they were giving us two coordinates and we were getting the difference in y and the difference in x to find what the gradient is. Now, in differentiation, they will not give you that. They're just going to give an equation, and you will need to use the equation to find that gradient. Okay, right? So we know that the gradient for this line here is going to be 3. We say that the change in y divided by change in x, so dy dx, is going to be equal to 3, right? So this means the change in y, which is the same as y at point 2, take away y at point 1, divided by x at point 2, take away x at point 1. This is basically going to be the same as what we call dy dx. Okay, you can look at it as difference. So dy dx, so this dy here stands for the change in y, and this dx here stands for the change in x, and that will give us 3. Now, from now on, in this topic, we're not going to be using y2 take away y1 this here. We're only going to be using this one here. Okay, so that's going to be normal now. So I'm going to take it off. Now, I want us to look at a formula that we're going to be using now, from now on. And this formula says that the result of differentiating y equals to something x with a number, a power at the top, where n is any number, is given by dy dx equals to nx n minus 1. Okay, right. I want us to use this to understand it. I'm going to take, I just basically want to take, I want to take off this x off first for you. That for the, I want to take it off for you for the time being. Okay, right. So let's just pretend that I've got a line y equals 3x. Now, obviously, this line, the gradient is 3, and the y-intercept is 0. I want to use this formula here to show that the gradient is 3, that dy dx equals 3. Okay, the first thing to do that is to write y equals to 3 and let x have a power that is clear. Now, if it's just x, we know that's always 1. Okay, now to find what the gradient is, which is dy over dx, we will need to do something. We take this power, which is the n that you're seeing here, right? We times it by the number in front of this x here. So we take this 1 times by the 3, which is going to be equals to 3 times 1, or 1 times 3, which is basically 3. Then you're going to still have the x, but the power of x, which was 1, goes down by 1, which is this formula here. So the n here I had was 1. You bring it in front, but I have 3, so you need to times it by that. Okay, and then you take away 1 from that power. So here I've got 3. X to the power 1 minus 1 is basically x to the power of 0. Now remember, anything to the power of 0 is equals to 1. So this bit here is the same as 3 times 1, which is just going to be 3. Okay, so that's how to do that. I want us to use this formula to try this example here, to differentiate each of the following. Right, so to find dy dx, we've just said one thing, that the first thing, you take this power and times the number in front here. There is 1 hiding here. So you're going to do 3 times by 1, which is going to be 3. Then the x, this power here is going to go down by 1. So you're going to have 3 take away 1, which if you simplify is going to be 3x to the power of 2. So that means that the gradient of this curve here, yeah, is going to be given by the equation 3 equals to x squared. Okay, and that's just enough for the time being. Right? Now, let's look at example B and example C. looking at this, dy over dx is going to be, you take this power times the front one by 8, so that's going to be 8. Then you copy the x, and this number here is going to go down by 1, right? So we're just going to have what? 3 there, okay? So that's going to be that. Now, when you have a longer one like this, you're going to do it in bits. We have y equals to x squared minus 6. Now, this 6x here, I can put 1 where x is. You know, x to the power 1 is just x. And where 5 is, I can introduce x as well. But this is going to be x to the power of 0 because x to the power of 0 is 1. And 5 times 1 is just 5. So this one doesn't change the value. It just makes doing it easy. So when I start to differentiate, okay, when I start to differentiate, I'm going to take these 2 times by the 1 in front here, which is going to be 2. And then the x, these 2, I will take away 1 from it now, which is just going to be 1 now. You don't need to try that one. Just leave it because we know it's 1. Now, then he's going to be 1 times 6, which is going to be 6. And then this power is going to go down by 1. So if you want, you can write 0 for the time being. And then for this one, you do 0 times by 5, which is obviously 0. Now, 0 times anything is just going to disappear. So that one there, I can just ignore. Okay? Now, all I need to do is now to simplify this bit. So this is going to be 2x, just writing it. Now, this x to the power of 0 is 1, and 6 times 1 is just 6. So that's going to be minus 6. And that's going to be the answer to that. Okay? Right. What I want you to do is to pause this video, and I want you to try question A all the way to question H, please. So try question A all the way to question H. Okay, hope you tried that. Right, so I'm just gonna pick one tricky one to do for you. So if I just do H for you quickly. So question H says y equals to 3x to the power 4. Now if I want to find the gradient, I want to find dy. Right, so I want to find dy dx. Then obviously we're going to take 4, we times by the 3, which is going to be 12. Then what's going to happen that this 4 is going to go down by 1. So that's going to be 3 basically. Okay. So question H, that's the answer. Now I could do question F for you as well. So if you're going to do question F, let's do question F. It says that y equals to x to the power of 6 minus x to the power of 5 plus x to the power of 4. Now doing that, I've got dy dx. 6 times by 1 is going to be 6, and then the 6 is going to become 5 if you take away 1 from there. Then I've got 5 times by 1 here, but you see this minus, so that's going to be minus 5. X, the 5 is going to go down by 1, so it's going to be 4. And then for this one, I'm going to have 4 times by 1 here, which is going to be 4. But then the 4 is going to go down by 1, so it's going to be like that. Okay, so that's going to be the answers to that. Right, so I want you to pause the video now. Again, and using your red pen or green pen, I would like you to mark question A all the way to question H and put your answer out of 8. Right? So mark your work and put your answer to be out of 8. Okay? Okay. That's well done. Right. Okay. Right. So I want you to pause the video again. And if you now just try quickly question, pause the video and try question I all the way to P. Okay, hope you've tried. What I'm going to do now, I'm just going to do question O for you quickly. So you got y equals to 7 plus 4x minus 2x squared. Okay. Now, when you want to differentiate things, the first thing I normally do is that if you have a number that has got no x, you can always put x to the power of 0. It does make a difference because this is just 1. 1 times 7 is just 7. And then the other ones that don't have any power with the x, it means that there's 1 there. So this one has got 1 hiding there. And then I've got minus 2x squared. Okay? I've not differentiated it yet. Now I'm going to differentiate. I'm going to find dy dx. I'm going to find what the gradient would have been. Now we take this power times by 7. 0 times by 7 is 0. And 0 times anything just disappears. So that point there, we only have 0 there. Okay? And then here I've got 1 times 4 is going to be 4. And then I've got 4x to the power of 0 now because I've taken 1 from there. So that's going to be 0. And then this one I'm going to have minus 2 times 2 is 4. And then the power there is going to go down by 1. Now, then all you need to do is to tidy up. I've got 4 here because x to the power of 0 is 1. So it's 4 times 1 is just 4. And then the other side, I've got 4 times by x because x to the power of 1 is just x. So that is the answer for you for that. Right, I would like you to, if you want to pause the video quickly, and if you just want to use the answers here to mark your work, please. So pause the video and use these answers to mark your work. Okay, hope you done well on that one. And that's going to be the end of our first session on differentiation.